Assalamualaikum. Now we present our assignment Thermodynamic and Heat Transfer Conduction Graphical Analysis of Heat Transfer. The lecturer is Prof. Madya T.S. Dr. Zahir bin Hassan. This is our group members. First, the leader is Aqil Faris bin Fauzi. Second, Muhamad Muqri bin Razali. Third, Muhammad Faris bin Yahya. Fourth, Muhammad Hafiz Azril bin Muhammad Nordin. Now I will explain the introduction first. This assignment focuses on conducting a graphical analysis of heat transfer through fine surface. Students are required to design different fine configurations, simulate heat transfer using suitable software, and present their findings through a short slide presentation and a video. The task aims to develop student understanding of heat conduction, enhance their technical creativity, and improve their communication skill in presenting engineering analysis. The objective: first, enable students to design and conceptualize different front surface configurations creatively. Second, develop practical skill in performing heat transfer simulation using appropriate software tools which is SolidWorks. Third, analyze and interpret the result of heat transfer simulation through graphical method. Four, enhance student ability to communicate technical information effectively through multimedia presentation. Five, foster teamwork and timely completion of group assignment to achieve a comprehensive understanding of conduction heat transfer.
Hi, Assalamualaikum. My name is Muqri bin Razali and my metric number is B112310480. So basically right here we have two design with same specification. So as you guys can see, for the ambient temperature in Celsius is around 28 to 34, and for the fins base size the spec is 40 times 40 millimeter, and for the convection coefficient is 5.03, and average heat flux on cold side is 1500. Average temperature on cold side is 76.6, and average temperature on hot side is 97.3. So going through the first design. So basically right here you can see for the base the height is we put as 10 mm, and the fin height is 30 mm. So basically this is the side view, and this is the top view, and this is from the side view. So basically this design, this is the heat sink. It is used to remove heat from electronic devices like chips, LEDs or power modules. So the bottom part called the base sits directly on the hot device and quickly absorbs the heat. So the tall is the thin plates on top are called fins. These fins increase the surface area so that more heat can escape into the air. As air moves through the gaps between the fins, it carries the heat away. This helps the device stay cool and work properly. This design is simple but very effective for cooling electronic without using moving parts like fans. So that's all from me. Thank you.
Muhamad.
Assalamualaikum, my name is Muqri bin Razali and my metric number is B112310480. So I'm going to explain about the first design for result. So basically this image shows the thermal simulation result of the heat sink model that previously shared. So the color gradient represent how heat is distributed throughout the heat sink. So as you guys can see, the bottom part of the heat sink is the hottest, with a temperature close to 97.3 degrees Celsius, shown in red color. So as you move upward through the fins, the temperature gradually decreases. So the top of the fin, so this top is the coolest with the temperature around 76.6 degrees Celsius shown in blue color. So the color transition from red to blue shows that the heat is flowing from the bottom is the hot area to the top, the cool area, which means the heat sink is doing its job, moving heat away from the base, releasing it into the air. So the smooth color gradient suggests that heat is spreading evenly through the fins, which is a sign of good thermal performance. So this means like as you guys can see, the color gradient, the smooth color gradient is really nice. So it shows a good sign of thermal performance. So that's all for me. Thank you.
Assalamualaikum. My name is Muhammad Faris bin Yahya. I will present about the design tool. Okay, for this is the front view. This is the top view, and this is side view. Uh, for the fin in front view, the height is 40 mm. The base is 10 mm. For the top view, gap fin to fin is 2 mm, and for the fin is 5.5 mm. Okay, for the okay, next. The design is a 3D model of heatsink, typically used for thermal management in electronic or mechanical system. In features a solid base plate with a series of vertically extrude fin arranged in a cross fin or grip pattern. The primary purpose of this structure is to dissipate heat efficiently by increasing the surface area exposed to air. The solid base conduct heat away from the heat generating component, while the numerous fin enhance heat transfer to the surrounding air through convection. The perpendicular fin orientation may also promote better airflow in multi-direction, making the design suitable for both natural and forced convection cooling. This type of heat sink is commonly used in applications such as CPU, power electronic, LED module, and other high-power devices where effective heat dissipation is critical. Assalamualaikum. My name is Muhammad Faris bin Yahya. I will present about result design tool. This image shows a thermal simulation result of the heat sink design. The temperature distribution is color coded, ranging from red hot to blue cool, with a scale from 76.6 derajat Celsius to 97.3 derajat Celsius. The base of the heat sink, where the heat source is applied, reaches the highest temperature of approximately 97.3 degrees Celsius. As heat transfer from the base of the fin, the temperature gradually decreases along the higher of the fin. The tip of the fin are the coolest area, with temperature as low as around 76.6 degrees Celsius. This result confirms that the heat sink is effectively conducting heat away from the base and dissipating it through the fin, with a clear temperature gradient that indicates successful thermal performance. The cross-fin structure enhances this cooling effect by maximizing surface area and facilitating better heat transfer to the surrounding air. Thank you.
Hello, Assalamualaikum. My name is Aqil Faris bin Fauzi and my message number is B1123101009. So for the assignment, this conclusion. For the assignment, we design two different fins using SolidWorks. Then we run a heat transfer simulation to see how well each fin transfer heat. We set the conditions like temperature and airflow and then see how the heat moves through the fins. The simulations shows which design is more effective at cooling. Finally, we make a short presentation with pictures and explain which fins works better and why. Using SolidWorks helps us see the difference without making real models. So, the conclusion for this assignment. In conclusion, the conduction graphical analysis and simulation of the fin surface demonstrate the effectiveness of different fin design in heat transfer. The results provide valuable insights into optimizing fin geometry for improved thermal performance, thereby enhancing the overall efficiency of heat transfer system. That's all from us. Thank you.